As we look at this rock cross-section, we can use angular conformity to break the rock into 4 chunks. We have the top layers here that basically are running horizontal. We have another segment in this middle section whose bands are running parallel to each other, but definitely at an angle compared to the red section. We have another section of rock that was probably laid down horizontally and then greatly uplifted to make the bottommost section the green section. And finally, we have this piece that cuts across most of the layers that represents an igneous intrusion. The law of horizontality tells us that new sedimentary rocks are laid down horizontally. So these top 2 layers are horizontal, which tells us that they have not been disturbed. Consequently, we can assume, using the law of superposition, that the topmost layer is the most recently formed, followed by the layer underneath that, which is stratum E. We can see that the angle abruptly changes here, so that likely represents an erosional occurrence or an unconformity. Notice that our igneous intrusion ends abruptly at that unconformity. It cuts through all of the layers underneath it, but stops there. So that means that the igneous intrusion had to exist when the erosion took place to cause the unconformity. So G is our next stratum. Moving downwards into the earth and deeper back in time, we can assume that these layers were all laid down horizontally at one point and then were uplifted to make them angled. And so the law of horizontality and superposition tells us that the topmost layer probably is the youngest of that bunch, followed by C, B, and A. And looking at what's left, we see that we have the layers that were laid down horizontally and then dramatically uplifted. We also have 2 events. We have an angular unconformity here, so there is likely erosion taking place. And we have a fault. So the question is, which occurred first, the angular unconformity or the fault? So we can start with the layers of the rock. We know the layers of the rock are H at the bottom, because that's the bottommost layer, followed by I, J, K, and L. But when did M form, and when did the unconformity form? Well, our clue comes from the fact that M, the fault, ends at the unconformity. So, fault M had to exist when the erosion that caused the unconformity occurred. In other words, it would not have been cut off by the unconformity if the fault had occurred afterwards.